Hi everyone, welcome to my channel. This is Mrs. Anderson, and in this video I'm going to talk about right triangle trigonometry. So I want to first start off by going over the basics for this right triangle trigonometry. And there's this abbreviation SOHCAHTOA, so I want to go over where exactly that came from and how you can use it. So there's three big trig functions that come into play when we talk about trigonometry in general, and so I'm going to go over those three here first. The first one is called sine, and this is when you set up the opposite over the hypotenuse. The second is called cosine, and that's when you set up adjacent over hypotenuse. The third is called tangent, and that's when you set opposite over adjacent. So that's where this abbreviation SOHCAHTOA comes in. The SOH comes from your sine. Sine for the S, and then O and H for opposite and hypotenuse. CAH is for cosine function. C is cosine, A is adjacent, H is hypotenuse. Tangent, the TOA, T for tangent, O for opposite, and A for adjacent. So if you can remember this simple little phrase SOHCAHTOA, this will help you understand how to set up sine, cosine, and tangent for any problem. So how do we use these three, and how do you know which one to use? You base all of your setup that you're trying to do for your problem based off of an angle. And you're either using that angle to help you find a missing side, or you're trying to use one of these trig functions to solve for a missing angle. The hypotenuse is always going to remain the same for all right triangles. When you have a right triangle, you should see a little box. Down by my capital C in my picture here on this slide, you should see that little box, and that tells you that that is where the 90-degree angle is. The side directly across, if I drew an arrow going straight from big C to the little c in that picture, that little c would be representing the hypotenuse side. So that side will always be the same. So whenever I'm doing a problem with SOHCAHTOA, or any type of tangent problem, or sine problem, or cosine problem, I always set up and I mark where my hypotenuse is, because that will always be the same and it will remain unchanged. The opposite and adjacent sides will change based on which angle you're working with. So if I was looking off of capital A or capital B, that's going to change the opposite and the adjacent side. Now opposite would again be if I went straight across, and adjacent, remember, means next to. So I think about which side is connected to that angle that isn't the hypotenuse. So let's do a practice problem here. We're just going to set up the basic trig functions for the angle A. So if I wanted to do sine, that would be opposite over hypotenuse. So opposite of capital A is the 5, and then you put that over the hypotenuse, which would be the 13. Cosine would be adjacent over hypotenuse. So the adjacent side is that 12 because it's next to the A, and 13 is still going to be the hypotenuse, so 12 over 13. Tangent is going to be the opposite side over the adjacent side. So again, looking up at that capital A, straight across from that would be the 5, so that's opposite, and the adjacent side is that 12, so 5 over 12. Let's do the same thing now, but for angle B. So sine of B would be 12 over 13. Cosine of B would be 5 over 13. And tangent of B would be 12 over 5. So let's get into how can we use trigonometry to solve for missing parts, missing sides, and missing angles. We can use the trig functions to help us solve for any missing parts. To solve for a missing side, use the angle provided to help you set up your trig function. So there's going to be one angle beside from the 90-degree angle that you're going to want to use to help you set up your trig function. Rewrite your problem for the missing variable, and then use your calculator to help you solve the problem. You will definitely want a calculator when you're trying to evaluate with sine, cosine, and tangent, so make sure that you have one handy when you're trying to do these problems. To solve for a missing angle, it has a lot of the same steps that we had for solving for a missing side. This time, use the missing angle to help you set up your trig function. So discover from the angle that you're looking for, what's the hypotenuse, what's the adjacent side, what's the opposite side. Again, rewrite your problem for that missing variable, and then for the missing angles, you'll have to use the inverse trig function in order to solve for that. So it'll look a little bit different. It's going to have a -1 up in the corner next to it because we use that to help us find our angles instead of just regular sine or cosine or tangent. And again, you're going to want to use your calculator to help you solve these problems. So let's take a look at some practice problems here. I'm going to start with the one on the left first. So I want to use trig here to help me solve for that x, that missing side. So if I'm looking at x, going off of that 32 degrees, x is opposite from 32 degrees, and 4 is opposite of that 90-degree angle, so that would be the hypotenuse. So x is the opposite side, 4 is the hypotenuse side. So that's going to tell me that I'm going to be using sine. So to set this up, we do sine and put in that 32 for where that angle would be. So sine of 32 equals x over 4, opposite over hypotenuse. Now to rewrite this, I need to get 4 out of that denominator. So using basic algebra, we're going to multiply both sides by that 4. And so we have x equals 4 times the sine of 32. This is when you're going to want to type this into your calculator and evaluate. So we're going to get 2.1 meters for x. Going over to the second picture on the right side of the screen here, we're going to also solve for x, but this time it's in a different place. Now you also have 76 degrees is what's provided for you. That 70 meters is across from the right angle, so that's your hypotenuse. The x, since it's next to the 76 degrees and it's not the hypotenuse, means that it would be the adjacent side. So I have adjacent and I have hypotenuse, which would be cosine. So cosine of 76 would be x over 70. Again, multiply both sides by 70 in order to get x alone. So we have 70 times the cosine of 76. Typing that into my calculator and rounding to the nearest tenth, I get 16.9 meters. For these two problems, we're going to solve for the missing angle. So the one on the left side, again, I would look at that angle, and that symbol down there is the Greek letter theta, and that's used a lot in trig to represent the missing angle. So you'll see that symbol a lot. So across from theta down there, across from it is the 3, so 3 is opposite, and 5 would be the hypotenuse because it's across from the right angle. So I'm using sine. Now this time the missing piece goes where that capital letter was when we were setting up our basic trig functions. So the sine of theta is equal to 3 over 5. Now because I'm finding an angle, I'm going to have to use my inverse function. So I'm going to do sine to the -1 and then 3 over 5. Now if you're using a calculator of some sort, you will probably have to hit your second key, and that's usually in the top left hand area of your calculator. So you'll hit second and then you'll hit your sine button, and you should see sine to the -1 pull up in your calculator. Then type in 3 over 5 or 3 divided by 5. And usually for angles they like us to measure to the nearest whole number. So for this one you should get 37 degrees. For the second one, using the same setup, we have theta down there is the missing angle, and across from it is 12, so that is the opposite side. 7 is the adjacent side, so opposite over adjacent is from the TOA part of SOHCAHTOA, which would mean we're using tangent. So tangent of theta would be 12 over 7. Again, we'll have to use our inverse function to solve for theta, so tangent to the -1, 12 over 7, and rounding to the nearest angle, we get 60 degrees. If you're ready to give it a try, I've created a practice quiz on a website called quiziz.com, and it is a multiple choice platform where you can go and practice the skill you just learned. The link to that can be found below in the description, but I've also included it here for you to type into your URL if needed. I hope you learned something from this video, and thank you for watching.